Hello everyone and welcome to Van Tech Corner. In the previous video, we have installed OpenWRT on the Intel N5105 2.5Gb Ethernet router PC. We have also run a 1-to LAN throughput test with iPub3 and OpenSpeedTest. In this video, let's check out the OpenVPN, Wireguard VPN Throughput, and the SQM QoS performance of this router. I will be using this simple network setup for the test. The N5105 router PC and the test server are connected to the LAN port of the NanoPi R5S. The link speed is now 2.5 gigabit per second. The test server is powered by the Intel Xeon i3-1230V2 with 16 GB of RAM. Therefore, it should be powerful enough to run OpenVPN and Wireguard VPN as a server. Let's get started with OpenVPN. First of all, we will need to install OpenVPN. This is very simple. You just need to update the package database and install OpenVPN-OpenSSL and then LuCI app OpenVPN. You can see my OpenVPN client video for the step-by-step installation tutorial. Now, the tuner is up and ready. Let's run the test with OpenSpeedTest. The throughput is not bad at all. It is 740 Mbps download and 466 Mbps upload. With iPub3, I got 457 Mbps throughput in normal mode and 828 Mbps when running the test in reverse mode. For Wireguard VPN, the installation on OpenWRT 22 is much easier. You only need the Wireguard package and that's it. In the new version, you can drag and drop the Wireguard configuration file instead of manually copy and paste. This will make the installation faster. Now it is time for the test. Very good, we got 931 Mbps download and 899 Mbps upload with OpenSpeedTest. iPub3 throughput in normal mode is 784 Mbps, and when running the test in reverse mode, the throughput went up to 967 Mbps. The last test in this video is SQM QoS. The application requires one package, LuCI app SQM. Let's install it in the software tab. Before enable SQM QoS, let's check the ping response time from the upstream routers when the throughput is high. Here, I try to ping 192.168.2.1. The normal response time should be 1 ms. However, when we are running the OpenSpeedTest at around 2300 Mbps, the ping response time went up to 6 or 7 ms. The same happened when I try to ping 1.1.1.1 and run the test. We can see that the minimum response time is 25 ms and it peaked to 33 ms. The first speed I tried with SQM QoS is 2500 Mbps download and 2500 Mbps upload, with cakes and piece of cakes, and the overhead value is 44. We can see that the ping response time is not stable. That's why I try with a different value. Things getting better when the SQM QoS speed is at 2000 Mbps. The ping response time from the upstream routers only increased by 3 ms, which is really good. However, the ping response time from 1.1.1.1 is not stable during upload. That is why I set the SQM QoS value to 2000 Mbps download and 1800 Mbps upload. This time, the ping response time from the upstream router is stable and only slightly increased during the test. At the end, to simulate the traffic from different sources, I ping 1.1.1.1 and run Speedtest.net, fast.com, and OpenSpeedTest at the same time. Speedtest.net and fast.com send and receive the data from the internet, where OpenSpeedTest will run locally. I hope a mixture of the traffic can simulate the real-life scenario. So far, I can see that the ping response time remains stable at 26 or 27 ms. Perhaps this is the best SQM QoS throughput for now. I'm going to end the video here and we will see more in the next video. If you have any idea how to properly run the SQM QoS locally, please share in the comment section and I'm really happy to know that. Thanks for watching and see you all.